You ready to dive into the crazy world of AI?
I know I am.
We're going to go deep on the history of artificial intelligence.
Okay.
But not just like the latest buzz.
Right.
We want to go way back
Yeah.
to the twists and turns and aha moments.
The stuff most people don't know about.
Exactly. That led us to where we are now.
Cool.
Turns out there's a lot more to the story than just ChatGPT.
Oh, yeah, for sure.
We have an expert speaker here with us to unearth all these, hidden gems of AI knowledge.
Yeah, I'm excited. It's like opening a treasure chest of forgotten AI.
I love that.
Yeah.
So get this. Did you know that back in the 1950s, people thought we'd have human-level AI within decades?
Oh, yeah. I've heard that it's a pattern we see a lot in AI's history, this
Like crazy optimism.
Yeah, but even those so-called failures often had these brilliant ideas that are worth revisiting.
That's so true.
It's like we can learn from the past
Absolutely.
and apply those lessons to the future of AI.
100%. So let's rewind all the way back to, the OG genius Alan Turing. And the interesting thing is he wasn't even trying to build a computer.
Right, he was tackling this super complex math problem.
What was it? What was the problem?
It was called the problem.
Okay.
And he wanted to know if there was a guaranteed way to solve any mathematical problem just by following a step-by-step process. And to try to figure this out, he came up with this idea of a theoretical machine,
Okay.
what we now call the Turing machine,
I see.
that could follow a set of instructions.
So like the ancient ancestor of a computer program.
Exactly.
Wow.
What's mind-blowing is that this very simple idea, a machine following instructions, is the foundation of every computer we use today.
That is mind-blowing.
From your phone to those massive supercomputers
Crazy.
running AI models.
It's amazing to see how those basic building blocks paved the way for the AI we have now.
It's really remarkable.
So Turing's brilliance, it didn't stop there.
No, not at all.
He also gave us the famous Turing Test.
Right.
Which is the idea that if a machine can convince you it's human in a conversation, it's basically intelligent.
Yeah, like a classic imitation game.
Exactly. But does that really hold up?
As a measure of true intelligence.
Yeah.
Well, that's a great question.
I mean, a chatbot might be able to trick you, but does that mean it understands the world the way we do?
I think that's a really important point.
Yeah.
The Turing test is definitely a thought-provoking idea,
For sure.
but it really focuses more on behavior than genuine understanding.
Right. So like a chatbot might pass the test,
Right.
but does it really grasp what it's saying?
Does it have emotions or self-awareness or ponder the meaning of life like we do?
Yeah, it's more about mimicking human conversation
Yeah.
than actually replicating the complexity of human thought.
Exactly.
Okay, so this realization,
Yeah.
this led researchers to explore all these different approaches to creating machines that could truly think like humans.
Right.
This period became known as the golden age of AI,
Yeah. The golden age.
where researchers were really trying to decode the secrets of human intelligence.
That's right.
So crack the code of how our brains work and then translate that into algorithms,
Yeah.
which sounds incredibly ambitious.
It was incredibly ambitious.
So they tackled all these classic problems, like the traveling salesman problem.
The traveling salesman
It's just
trying to find the most efficient route
Yes.
through multiple cities.
The idea was, if we can figure out how we solve these problems,
Right.
maybe we can teach computers to do the same.
Exactly.
Which seems logical, but did they actually succeed?
Well, not always. They ran into some roadblocks along the way.
Like what?
Well, they discovered that some problems are just incredibly complex,
Okay.
even for really powerful computers.
Huh.
Like, take the traveling salesman problem, for example. As
Yeah.
you add more cities to the problem,
Yeah.
the number of possible routes grows exponentially to the point where it quickly exceeds the number of atoms in the universe. It's mind-boggling.
That's wild. So how
It's-
did they deal with this, explosion of possibilities?
Well, they realized that brute force computation wasn't always the answer.
Okay.
They needed a new strategy,
I see.
which led to the development of expert systems.
Expert system.
Instead of just relying on raw computing power,
Okay.
they tried to equip machines with knowledge,
Okay.
similar to the rules a doctor might use to diagnose a patient.
So instead of mimicking the process of human thought,
Right?
they were trying to capture the knowledge that drives those processes.
Exactly.
That's interesting.
And this actually led to some fascinating projects, like Psychus,
Which it did.
aimed to encode all of human knowledge.
Hold on. All human knowledge. All of it.
That sounds like a colossal undertaking.
It was incredibly ambitious.
Wow.
And while it didn't achieve its ultimate goal,
Right.
it showed just how far AI researchers were willing to push the boundaries.
It's like trying to build a digital brain
Yeah.
that contains everything humanity knows. That was the idea.
So speaking of different ways of thinking,
Yeah.
I came across this thing called logic programming while researching for our deep dive.
Oh, logic programming. Interesting.
It sounded fascinating,
It is
but a
fascinating.
little over my head, if I'm being honest.
Well, it's a beautiful idea.
Okay.
It's rooted in formal logic.
Okay.
Think of that classic example, all men are mortal.
Okay.
Socrates is a man.
Yes.
Therefore, Socrates is mortal.
Right.
Logic programming tries to translate that kind of logical deduction into code.
So instead of giving the computer specific instructions for every situation,
Right?
you could teach it these logical rules and let it figure things out on its own.
Precisely.
Wow.
It was a very elegant approach in
Okay.
theory, but it faced challenges
Okay.
when applied to messy real-world problems.
I see. It's interesting how the rise and fall of all these different AI approaches reflect our evolving understanding of intelligence itself.
It is, isn't it?
It really is. So what happened after logic programming?
Well, a researcher named Rodney Brooks came along
Okay.
and kind of shook things up.
Really?
He challenged this prevailing focus on abstract reasoning
Right.
and argued that robots need to experience the world directly to develop true intelligence.
So instead of just thinking they needed to start doing
Exactly.
Yeah.
He was a champion of behavioral AI.
Okay.
He believed that intelligence arises from interaction with the environment,
I see.
not just pure thought.
Okay.
His approach was to build up intelligence through layers of simple reactive behaviors.
So less about planning everything out in advance,
Right.
and more about responding to the environment in real time.
Precisely.
Huh. So that's like how a Roomba navigates a room.
It is very much like that.
Wow. And speaking of robots interacting with the world,
Yeah.
that brings us to your area of expertise.
Multi-agent systems.
Tell me about that.
Imagine a world where you have your own personal AI agent
Okay.
that can schedule your meetings,
Okay.
negotiate deals, even collaborate with other AI agents on your behalf.
Wow. So it's like having a whole team of AI assistants
Exactly.
working together
Yeah.
to make your life easier.
That's the idea.
That's incredible.
It's a glimpse into a future where AI isn't just this one big monolithic system,
You're right.
but a network of intelligent helpers.
Working together
Yeah.
to achieve complex goals.
You already see this happening in some ways, like self-driving cars communicating with each other.
To optimize traffic flow.
Exactly.
Wow. Or smart grids.
Yeah.
Managing energy distribution.
Right?
That paints an incredible picture of a future powered by AI collaboration.
It does, doesn't it?
It does. But how does all of this connect to the deep learning revolution
Okay.
that's happening today with neural networks?
That's a great question.
Yeah.
And it takes us to a really fascinating turning point in AI history.
Okay, let's talk about that.
You're right.
So we were talking about a turning point in AI history.
Yeah, pretty major one.
Did deep learning just suddenly appear out of nowhere?
Yeah. Not exactly. While symbolic AI was having its moment,
Okay.
another approach was kind of bubbling away in the background.
Okay.
Artificial neural networks.
Neural networks.
These networks took inspiration from the structure of the human brain,
I see.
and they were all about learning from data rather than being explicitly programmed.
So instead of feeding computers a set of rules, researchers were basically saying,
Yeah,
here's a ton of data, figure it out.
you got it.
Wow.
It was a radical shift from the symbolic AI approach.
Okay.
Now, early neural networks were pretty limited,
Okay.
but there were a few crucial breakthroughs,
Okay.
like the development of backpropagation in the 1980s.
Backpropagation, that sounds like something out of a sci-fi movie.
It does, doesn't it?
What is it? What's the significance of that?
Well, think of it as like a super efficient learning algorithm
Okay.
for neural networks.
Okay.
Backpropagation allowed researchers to train much larger and more complex networks.
So bigger networks, better learning.
Right.
And more data. Is that what led to the deep learning revolution?
You nailed it.
Wow.
By the 2000s, two things happened.
Okay.
That supercharged deep learning.
Okay.
First, we had access to massive amounts of data thanks to the internet
Right.
and the digitization of, well, everything.
Everything.
And second, we had powerful computers,
Okay.
especially GPUs,
Okay.
which were initially designed for graphics.
Oh, interesting.
It turned out to be perfect for training these massive neural networks.
Those things that make video games look so realistic.
The very same.
Wow, who would have thought
Yeah.
that the technology that could render such stunning visuals could also power the AI revolution?
It's an interesting twist.
It really is. So this approach that was once dismissed
Right.
is now the driving force behind some of the most impressive AI achievements.
Yeah, it really is quite remarkable.
It's a testament to the power of mimicking the brain's structure.
Absolutely.
Deep learning has led to these incredible advances
Yeah.
in image recognition,
Mm.
natural language processing,
Yes,
and even things like game playing.
that's right.
And of course, the poster child for deep learning has to be ChatGPT,
ChatGPT.
a language model that can hold conversations,
Yes.
write different kinds of creative content,
Yeah.
answer your questions in an incredibly comprehensive way.
It can do a lot.
It seems like it can do it all,
ChatGPT and other large language models
right?
are based on a specific type of neural network architecture
Okay.
called a transformer,
Transformer.
which was introduced in 2017.
Didn't you mention that transformers were originally designed for predicting the next word in a sentence?
That's right.
Huh.
The transformer architecture was a major breakthrough
Okay.
for natural language processing.
I see.
It allowed models to process text in a much more sophisticated and efficient way.
So this seemingly simple task of predicting the next word
Right.
unlocked this whole new level of language understanding
Yeah.
for AI.
Yeah, it was a game changer.
That's incredible. But even with models like GPT-4, there are still things they struggle with, right?
Absolutely.
Like what?
While these models are amazing at mimicking human language,
Right.
they still haven't quite mastered true logical reasoning and problem solving.
So it's like they can talk the talk,
Yeah.
but they haven't quite grasped the deeper meaning behind the words.
Right.
So they're still missing that common sense element that we humans take for granted.
Exactly.
Oh.
So what now?
And that's why understanding the history of AI is so valuable.
Okay.
It reminds us that progress isn't always a straight line.
Right.
We might need to revisit some of those forgotten approaches
Okay.
to unlock the next level of AI.
So we've journeyed from rule-based systems to the intricate world of neural networks and deep learning.
It's been quite a journey.
But are those the only paths to AI?
Well, it's a good question.
Are there other approaches out there that might hold the key to those missing ingredients?
There's another approach gaining traction
Okay.
called neurosymbolic AI.
Neurosymbolic AI. It's all about combining the strengths of both worlds.
Okay.
The logical reasoning of symbolic AI
Okay.
and the learning capabilities of neural networks.
So a hybrid approach.
Exactly, a hybrid approach.
That sounds intriguing. How does that work in practice?
Well, imagine this symbolic AI is great at representing knowledge and rules.
Okay.
Like those logical statements we talked about
Fair.
earlier. Neural networks, on the other hand, excel at finding patterns in data.
Okay.
Neurosymbolic AI aims to merge these two strengths,
Okay.
allowing AI systems to learn from data and reason logically about what they've learned.
So it's like giving neural networks a boost of common sense and logical reasoning?
You got it.
That's cool.
We're already seeing some really promising results
Right.
in areas like robotics,
Okay.
where neurosymbolic AI is helping robots understand and interact with the world more intelligently.
It definitely sounds like a promising avenue for AI research.
It does.
But this brings up another question. How do we even define what intelligence is?
Oh, that's the big question.
Is there a universally accepted definition?
That's the million-dollar question.
Maybe the billion-dollar question at this point.
Maybe.
And one that philosophers and AI researchers have been grappling with for decades.
Yeah.
There's no single universally agreed upon definition.
Really.
Some define it as the ability to learn and solve problems,
Mm-hmm.
while others emphasize things like adaptability,
Yeah,
creativity, or even consciousness.
that's right.
It seems like defining intelligence is just as complex as building it.
It really is.
It really is. And that complexity is reflected in all the diverse approaches we've seen in AI research.
I think that's a good point.
Each approach is essentially a different hypothesis about what intelligence is
Right.
and how to create it.
Yeah, that's a good way to put it.
So we've explored symbolic AI, neural networks, deep learning, and even this fascinating hybrid approach called neurosymbolic AI. Each has its own strengths and limitations.
For sure.
With all that in mind, where do you see AI heading next?
That is the big question, isn't it?
It is. If you had a crystal ball, I think you'd be a very rich person.
That's right.
But in all seriousness, predicting the future of AI with any certainty is impossible.
It is, but one thing seems clear.
Okay.
The future will likely be shaped by a combination of these different approaches,
Okay.
each contributing its own unique strengths.
It's like a melting pot of AI ideas,
I like that.
all blending together to create something new and potentially revolutionary.
Yeah, I think that's a good analogy.
And it's not just about the technology itself.
Right.
We also need to think about the ethical implications of AI,
Yeah.
its impact on society,
Uh-huh.
and how we can ensure that its development benefits all of humanity.
I think those are all critical considerations.
They really are. So we've got to learn from the past
Yes.
to help shape a future where AI is a force for good in the world.
Absolutely.
Who knows what amazing breakthroughs are waiting for us?
It's an exciting time to be working in AI.
It really is. Maybe we'll finally unlock the secrets of consciousness,
That would be amazing.
develop AI that can truly understand and empathize with humans.
Or even create AI that helps us solve some of the world's most pressing problems.
Yeah, that's a future I'm excited to be a part of.
Me too.
But one thing that keeps popping up
Yeah.
in these discussions about AI is this idea of the singularity.
The singularity.
This point where AI surpasses human intelligence
Yeah.
and potentially takes over.
Right. The classic sci-fi scenario.
Is that something we should actually be worried about?
Well, the singularity is a captivating concept.
It is.
But it's important to remember that it's still a hypothetical scenario.
Okay.
And as we've discussed, AI development isn't a linear process.
Right.
There are still many fundamental challenges to overcome
Okay.
before we reach anything close to human-level AI,
Right.
let alone superintelligence.
So maybe we should focus less on those sci-fi scenarios
Yeah.
and more on building AI that improves our lives,
Right.
makes us healthier,
Uh-huh.
helps us live more fulfilling lives.
Absolutely.
And that's where things like explainable AI
Yeah.
become crucial.
Explainable AI.
We need to understand how AI systems arrive at their decisions,
Yeah.
especially when those decisions have a direct impact on our lives.
It's about trust and transparency.
Right. If we can't trust AI,
Right.
we'll never fully embrace its potential.
I agree.
Transparency and trust, those are key ingredients
Yeah.
for building a future where AI works for everyone.
100%.
And that brings us to another fascinating chapter in AI history,
Okay.
the rise of machine learning,
Machine learning.
which was once considered a fringe approach,
Right.
but has now become a dominant force in the field.
It's had quite a journey.
It's fascinating how AI research has gone through these cycles
Yeah.
of intense excitement, followed by periods of disillusionment,
Right.
like a roller coaster ride
It has been.
of breakthroughs and setbacks.
Yeah, and these cycles have really profoundly shaped the field.
In those early days,
Yeah.
there was this unshakable belief that we were on the verge of creating human-level AI.
There was so much optimism.
Right, but then we hit those limitations, especially with symbolic AI,
Uh-huh.
and it forced a shift in perspective.
It did.
So when that initial hype faded,
Yeah.
did people just lose faith in AI altogether?
No, not at all.
Okay.
It's more like they started exploring different paths.
Okay, so machine learning was one of those paths.
Right.
But even that had its own share of skeptics.
Oh, yeah, for sure.
For a long time, neural networks were seen as a dead end,
Yeah, they were.
too computationally demanding
Why?
and difficult to train.
Exactly.
It's funny how what's considered impractical one day
Uh-huh.
can become the hottest trend just a few years later.
That's true.
So what changed the game for machine learning?
Well, a few key factors converged.
Okay.
First, we saw this huge explosion in computing power,
Okay.
particularly with the development of GPUs,
Right.
which turned out to be ideal for training these massive neural networks.
So those things that make video games look so incredible
Yeah,
were a key ingredient in the AI revolution.
they were.
That's amazing.
Yeah, it's pretty remarkable.
So more computing power was one factor.
Uh-huh.
What else contributed to deep learning's rise?
Well, another crucial element was the availability of massive amounts of data.
Cool.
The internet and the digitization of information created this incredible treasure trove of data
Right?
that could be used to train these data-hungry neural networks.
So it's like the internet provided the fuel that deep learning needed to take off.
Yeah, that's a good way to put it.
But were there any other factors
Yeah.
that helped push deep learning to the forefront?
Yes, there were some really important algorithmic advancements,
Okay.
specifically the development of deep learning architectures
Okay.
that could effectively learn from this abundance of data.
Okay.
One of the most significant breakthroughs was the introduction of the transformer architecture in 2017.
Ah, yes. Transformers, the powerhouse behind ChatGPT. So this one architecture really changed the landscape for natural language processing.
It did. It enabled this major leap forward,
Wow.
allowing models to process text in a much more sophisticated and efficient way.
So when you combine that with massive amounts of data and powerful computing,
Yeah.
you get something truly remarkable,
You do.
like ChatGPT,
Right.
which can do things that would have seemed like science fiction just a few years ago.
It's true.
It's astonishing how far we've come.
It is.
It really is a testament to human ingenuity
Yeah.
and our relentless pursuit of understanding intelligence.
That's a good way to put it.
But even with these incredible advancements,
Uh-huh.
it's important to remember that these models are still tools.
Right.
They're powerful,
Yeah.
but they don't possess true understanding or consciousness.
Not yet, anyway.
I mean, they're not sentient beings.
Right.
They're complex algorithms that have become incredibly good at mimicking human language.
That's right.
But that still raises some intriguing questions about creativity.
Yeah.
If a computer can write a poem
Mm-hmm.
or compose a piece of music,
Yeah.
that moves us emotionally.
Yeah.
Does that qualify as creativity?
That's a deep philosophical question.
It is.
It touches on the essence of what it means to be human.
It really does.
Creativity has always been considered a uniquely human trait.
All right.
But as AI systems become more sophisticated, those lines are becoming blurred.
It makes you really ponder the nature of creativity and intelligence.
It does.
So where do we go from here? What does the future hold for AI?
Well, as we mentioned earlier, there's a lot of excitement around neurosymbolic AI, which
Right.
aims to bridge the gap between symbolic AI and neural networks.
Yeah.
It's a promising avenue for creating AI systems that are both intelligent and explainable.
Explainable AI, that's crucial.
It is.
Especially if we're going to trust these systems with important decisions.
Right.
We need to understand how they work.
Absolutely. And there are so many other exciting areas of research, like AI safety,
Yeah.
which focuses on ensuring that AI systems are aligned with human values
Right.
and don't pose any existential threats.
AI safety. That sounds like a whole other deep dive waiting to happen.
It does, doesn't it?
But for now, I think we've covered a lot of ground.
I think we have.
Wouldn't you say?
Yeah, we've explored this fascinating history of AI,
We have.
from Turing's early vision
Yes.
to the deep learning revolution and beyond.
It's been an incredible journey through the world of AI.
It has.
Who knew there were so many twists and turns,
Right.
so many different approaches,
Yeah.
and so many thought-provoking questions along the way.
It's a fascinating field.
It really is. So here's something to ponder as you go about your day.
Okay.
If a computer can write a poem that moves you,
Yeah.
or compose a piece of music that stirs your soul,
Uh-huh.
does that mean it possesses some form of creativity?
What do you...
Until next time, keep exploring, keep questioning, and keep learning.